Welcome to the Algebra Do Now 20.2 video key, and here we go. So after 3 hours, you were 20 miles north of Toledo. After 5 hours, you were 150 miles north of Toledo. So clearly you're traveling in some way. Could you organize this information into a couple of XY points? In fact, we can. Time and distance. Time will usually be X. So we have time of 3 hours. So we can say 3, 20. And then we also have 5 hours and 150 miles. So there you have a couple of XY points. This is what we call related data. Time and distance are related to each other. Now let's assume this is some sort of road trip, some sort of travel that's going on, and let's find a slope between these 2 points. So to find the slope, what we need to do is we get the change of y. So I'm going to call this point 1 and this point 2. And so we're going to do y1 minus y2, like that. And then down here we'll say x1 minus x2, and this will get us the slope. So let's do that. So y1 is 150, so we'll say 150. And y2 is the y value here, so that's 20. And we subtract 150 minus 20. Then we also set up with the x change, so the x1 is 5, so we say 5. And then we're going to subtract the x2, which is 3. And this will simplify into 130 Okay, 150 minus 20 is 130, and 5 minus 3 will be 2, which can further simplify into 65. Okay, because 130 divided by 2 is 65. So we can come up with a slope of 65. M equals 65. And M equals 65 is essentially the miles per hour. If we assume a steady rate, or at least it's the average miles per hour for that portion of the journey. So there you have it. It looks like I need to edit. No, I don't. I am all good. I tricked myself just now. So 1C, I thought this was a different question. If you came up with a slope of 65, you nailed it. That represents the speed of 65 miles per hour. So which linear equation would be best suited? So we got slope-intercept form, point-slope form, intercept form, and standard form. And since we have a couple of points and we have a slope, and neither of those points are intercepts, our best bet is one that's designed for a known point and a slope, and that's the point-slope form. Y minus the y value from a point on the line equals slope times x minus the x value from that same point there. So that is the point-slope form. That's the best choice. Slope-intercept form, we could work it out eventually, but it doesn't hand us the y-intercept. The intercept form, it doesn't hand us the x and y intercepts. And standard form really works best if you have intercepts as well, if you're dealing with this. But in terms of word problems, it's going to generally work with a couple of products that add up to something. So miles per hour times time, and a different number of miles per hour times a different time. That could work for standard form. Okay, so the point-slope form is best, as I noted above. And you've got these 2 points. We got the point at 320 and the point at 150. So, and we've got a slope. So we can use the point-slope form. So we can pick either one of those points. We can pick 320 or 150. Either point will do. And we're going to use the slope. So let's do that. So I'm going to say y, let's try it first with this one. Y, you might do that one. Y minus 20 equals 65 times x minus 3. And that equation will totally work. Oops, I need the parentheses there, though. And now we'll try it with the other equation. So just going to copy pasta that there. And instead of y minus 20, it would be y minus 150. And 65 stays the same. And then x minus 5. And those are your two equations that you could easily get using the point slope form. Both of these will graph the exact same line. Now, have a very steep slope of 65. It will go through the point 320, and it'll also go through the point 5150. All right, I hope that was